number 4 from the mixed review. It's a division problem. So you can factor and then flip, or flip and then factor. I think I'm going to go ahead and factor where everything is right now, and then I will flip my second. So what I like about this one is that everything is nicely factorable. It's a little messy because of the situation where we have the x to the 4th there. So let's look at this factoring kind of separately. Do it off to the side here. So I'm going to factor x to the 4th minus 29x squared plus 100. And a lot of this factoring, a lot of these multiplication division problems are really just factor and see what you can cross out. So with x to the 4th, don't get freaked out. If you don't have a number in front, you can just break it into x squared and x squared. So two numbers that multiply to 100 and add to negative 29 are negative 25 and negative 4. And those are perfect squares, so we can keep going factoring with those. X squared minus 25 factors to x plus 5, x minus 5. And x squared minus 4 is a difference of squares as well. X plus 2, x minus 2. Love it. So we can replace that whole guy in the top with that. X plus 5, x minus 5, x plus 2, x minus 2. Beautiful so far. All right, next we need to factor the bottom of that first fraction. So 2x squared plus 7x plus 6. You can absolutely factor this by guess and check. I factor these kind by split the middle. 2 times 6 is 12. Two numbers that multiply to 12 and add to 7 are 3 and 4. You can take out an x from the first two, and I can take a 2 out of the next. Already see something that I can cancel. I have an x plus 2 on top and an x plus 2 on bottom, so I'm going to go ahead and cancel those. Now don't forget that we have factoring to do on the other side. Let's go ahead and make this into multiplication. So what we're going to need to do now is flip this. So when I factor it off to the side, I'm going to go ahead and put my x squared plus 3x minus 10. The factors that go with that, when I flip my fraction, they are going to go on the bottom. So two numbers that multiply to 10, negative 10, and add to positive 3. Are positive 5 and negative 2. And again, since I'm flipping that fraction, we flip the second, so that second fraction is going to get flipped. That x plus 5 is going to go on the bottom, and so is times x minus 2. The last bit of factoring we need to do for this problem is, sorry, trying to pick a good color here. The 4x squared minus 9, again, that's going to go on top over here, because we flipped that fraction. This is another difference of squares. But we have to square root 4, x squared, and 9. So square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3. And we need one positive and one negative. Order does not matter with multiplication there. Now, since these two fractions are being multiplied together, we don't really need that multiplication symbol. We can just treat this as one big fraction. We don't have any addition symbols outside our parentheses, so we can just cancel our little hearts out. So anything you see on top that you see on bottom as well, those are going to cancel because they make 1. So let's see what we can cancel. I have x plus 5 on top here and an x plus 5 on the bottom there. I have an x minus 2 in green and in purple. And I have a 2x plus 3 in my navy blue up here and on the bottom. So this one is actually pretty beautiful. All of our denominators canceled. We only have 2 terms left in the numerator. What we have left is this x minus 5 and this 2x minus 3. You can absolutely leave that. You could multiply it out if you would like. If you would like to put it over 1, you can. I really like that problem. I love all the factoring and canceling. All right, if you have an additional question, please see me.